Year 7, I hope you are well. This is the second lesson in our physical separation lessons. Last lesson was evaporation. Today we are going to be looking at distillation. So I hope you are working in a nice quiet area and you have pen and paper or pencil and paper. So let's get started. So our driving question today is, what is distillation? So a bit of recap from the last lesson. So can you tell me, how would you separate a soluble, solid and a liquid? So pause the video now and have a go answer that question, please. Okay, so hopefully you pause the video and you have come up with the answer of evaporation. So yes, we can use evaporation to separate a soluble solid from a liquid. So don't forget that our solvent could be our water, our solution is our solid and our liquid together, and then our solute is the actual solid. So in that case, salt would be my solute and water would be my solvent, and mixed together would be my solution. So I could heat it up. Here I'm using a Bunsen burner, a crucible and a gauze. And another version or another way is I used basically the sun, energy from the sun. I had one on the plate and the plastic bag evaporation. I hope you can remember the results rather from that practical, what happened to the one in the plastic bag and what happened on the plate. Okay, so our next question. Why can mixtures be separated relatively easily? So pause the video now and answer the question, please. Okay, so hopefully you came up with that mixtures can be easily separated as the particles of each substance are not chemically joined or bonded to each other. That is vitally important to remember this. My mixtures are not chemically joined. My compounds are chemically joined, but my mixtures are not, and we can use various methods of physical separation. So filtration, distillation are two methods of physical separation. Think about a bowl of sweets. Let's say they're M&Ms and you want to pick out the yellow peanut ones. You can physically pick them out. This is still classed as physical separation because it is a mixture of M&Ms. So I hope that you're happy with that. If you're not, guys, please go back and look at the mixtures and compounds lessons from previous weeks. You do need to understand this. Okay, so moving on. Can you name the following parts of the atom? And for bonus marks, can you tell me the charge on the different particles inside the nucleus? Okay, pause the video and have a go now. Okay, so we know it's an atom. We know on the outside I have my electrons, and inside I have my protons and my neutrons, and they are inside my nuclei or nucleus. My electrons go around my electron shell. So the charge on my proton is positive. The charge on my neutron is none because it cannot hold a charge. The charge on my electron is negative. So electrons are negative, protons are positive, and neutrons have no charge. Okay, good. So I hope you're happy with all of these. Right, so distillation. What is distillation? So far we've looked at two separation techniques. We've looked at filtering and we have looked at evaporating. Filtering, I physically separate my solute from my solvent, and again evaporating, I physically separate my solvent from my solute. But for evaporating, it's important that they have different boiling temperatures. So for example, sand and water, so sand being my solute, water being my solvent, my water has a lower boiling point than sand does. So if I heat it up, the water will go from a liquid to a gas before my sand would. Okay, so they probably sit at home thinking, we can't boil sand, but if I heat sand to a high enough degrees, it goes from a solid into a liquid, it can become a glass, and if I continue to heat that, it will boil, and parts of it will start to evaporate. Okay, really, really high temperatures. Okay, so we're going to look at a new separation technique today. I would like you to look at the apparatus in front of you And I'd like to use your knowledge of changing states and states of matter, boiling points, everything we've gone through, and try and think about how this would work. So you'll have until the time of the bar goes red. Okay, so your time is up. Hopefully you come up with some ideas of what may happen. So what might happen around here, what might happen around here. So here we go. Right. Let's see how close you were to with your scientific ideas. So I'm going to play the demonstration first and we'll have a look at that, and then we'll come back and talk about the apparatus in front of us. Okay, so if you look closely, you'll see we have two different coloured molecules. They could be salt and water. They could be water and ink. So let's see what happens. As the temperature rises, they go from a liquid to a gas. There we go. And as they come down here, now cold water is coming through here. Pause that. Cold water is coming through here. So that gas will condense back down into a liquid. So if you see, I've got my particles here and my particles here, so they have become separated. Okay, so the same idea here. I've got my salt and my water. I'm heating it. It goes from a liquid to a gas. It comes down here, my evaporating tube, and here it cools down. Water comes in the top and at the bottom. So my gas goes from 100, 110 degrees down to below that, so 70, 80, and turns back into water. This is basically distillation. I'm distilling the water from my salt solution. Now, it's not only solutes we can use some solids or near solids. So we're going to look at fractional distillation. Now this is where you take a solid, we're looking at using some oils, and when you boil an oil, it comes apart in different sections. Think about a long piece of rope. I can cut it up into smaller sections. I can use smaller sections for different things. So this is what fractional distillation of oil is. And when I break oil down, or crude oil, it turns into different things that we can use. So look at the animation first. Okay, so there we have our oil in the bottom, okay, our crude oil mixture. Again, I heat it. Now, as it gets heated up, different fractions or part of that are released. Again, it's cooled down, and then I will be left at the end with a different part of my crude oil. Okay, so it's the same as normal distillation, but this is called fractional distillation. I'm taking a fraction of it at a time. There's still a lot left in here. Okay, this is another way you can do it in the lab. Bunsen burner, fractionating column, my condenser. So it's another way we can do it in the school, in the laboratory. Okay, there we go again. Look at that quickly. There we go. So fractional distillation. Now, obviously, it doesn't happen like this in real life. This is just an animation to show you how it would work. I wouldn't, if I wanted to make different fractions of crude oil, I wouldn't do it that way. I would use a bigger fractionating column. Now, there's a video we're going to watch. I'll put the link in the description of the video at the end when I post up on YouTube, and I will show you basically what happens. So again, let's watch the animation first. Okay, so there are my long bits of rope, or if you want, my crude oil. Now, as they come in, they are heated. And this heating breaks them down into smaller lengths. These are called long chain hydrocarbons. And my long chain hydrocarbons are broken down to smaller chain hydrocarbons. For example, my gas at the very top, or my petrol, or my naphtha, or my kerosene, or my diesel, or my oil, or my bitumen. These are all crude oil, but they are different lengths of my long chain hydrocarbons. So petrol, for example, is quite a small chain hydrocarbon used in cars. Naphtha, kerosene, slightly longer. We're looking at some aviation fuels. Diesel, used in cars. Oil, every oil you put in engine oil. Okay, not cooking oil, obviously, is a slightly longer one. My bitumens are really long chain hydrocarbons. So look at the animation, see what happens. My long chains go to the bottom, my shorter chains rise up. There we go. Track that one there. See where he goes. All the way up, all the way up, all the way up, all the way up, and here's a refinery gas. Okay, so it comes in and then it is broken down as it is boiled or heated up. Okay. Right, let's watch the video.
Industrial fractional distillation is used to separate crude oil into useful parts, or fractions. The process takes place in distillation or fractionating towers, which can be up to 60 meters tall. The equipment around them is used to heat the tower and the unrefined oil, and to prepare the separated fractions for transport and use. The tower is made up of many layers, and has an inlet for the crude oil and several outlets for the refined fractions. The crude oil mixture is preheated to partially vaporize it, and introduced to the column about halfway up. The tower is heated at the bottom to keep vaporization happening. Heavier fractions condense and flow down the column, because larger hydrocarbons have higher melting and boiling points. Lighter fractions vaporize and move up, because their boiling points are lower. To increase the purity of the separated fractions, heat transfer is encouraged between the hotter rising gases and the cooler falling liquids. The gas rises through bubble trays. These have specially shaped bubble caps, which help the gases and liquids to mix. Fractions with different sized molecules and different boiling points end up at different levels in the tower. These can be drawn off to be used for many different purposes. Smaller, lighter fractions from the top of the tower make good fuels.
Okay, I'm going to pause there a second. You're right. So this C stands for carbon, and you can see that my petrol C5 to C10. So it has 5 carbons to 10 carbons per chain. As they go down, they get longer. This is what I was trying to show my piece of rope a minute ago. It's broken down to smaller sections.
Heavier, larger molecules are good for lubricants, or can be cracked into smaller ones, including unsaturated alkenes, which may be turned into plastics through polymerization.
Okay, good. Right, so your first task for me is to read the boxes and fill in the blanks, please, for me. So pause the video now and have a go, please. Okay, so hopefully you pause the video. So you should be able to fill this in yourself. I'm not going to go through the answers. If you are stuck, go back and look at the video. If you are really stuck and really can't work it out, you should be able to send me an email or a comment and I'll get back to you. Okay, the next one again is a fill in the blanks, please, for me, guys. I would like to go through. I would like you to copy this out, please, if you possibly can, in your science book, if you are using one. If you are not using one, it would be a good idea if you could possibly get hold of one or even make one out of some loose paper. You should be using one by now. So, can you go through and fill out the blanks? Pause the video now and have a go, please. Okay. Good, so answers are there. Right, so our next lesson will be with Mr. Samuels. He'll be teaching you chromatography. That will be your last lesson this week, and as this is the end of a strange term, year 8, I will say keep safe, stay well. I look forward to, you never know, hopefully seeing you next term, maybe doing some online lessons. We've got a different look to science next term, so keep an eye on social media and check back in over the half term, and hopefully you'll start to see a few changes that I hope you're going to like. So take care, keep safe, year 8, and bye bye.